Hi, this is Tim. Welcome to the Mathly YouTube channel. Today we're going to be looking at problem number 20 from sprint round 12107. Now this was the state championship high school test that was given out in April of 2021. All right, let's take a look at what we've got here. We've got a sequence defined by p sub I such that p sub I is an integer. Okay, let's make sure we understand what this means, okay? It just means that we've got a bunch of p sub I, where I is going to be 1, 2, 3, and so on, right? So we've got these numbers, p1, p2, p3, up to whatever. And you can see that that shows up in this expression down here, okay? And p sub I, in other words, every one of these p1, p2, all the way up, is going to be an integer from 1 to 100, and none of them are equal. So all of these numbers are different integers, and I'll say less than 101, right? So, so they're all different integers less than 101. I should probably say that they're all different positive integers less than 101, right? So there aren't that many options here. All right, so let's talk about what we can have in the context of what the problem is doing. We want to know the possible increasing non-empty sequences. Increasing means that each one of these integers is getting bigger. Non-empty sequences means there has to be something, right? You can't just have no p's at all. You know, you have to have at least a p1 and possibly up to 100 of them. Well, I mean, the problem does say that all of these are different integers from 1 to 100. So, you know, maybe it's, you know, p1 is 1, p2 is 2, all the way up to p sub 100 is 100. The only problem is if we do that, we're not going to get rational results, right? If we have the square root of 2 here, for instance. Let's just say that somewhere in this, we have a 2, right? Now, obviously, a 2 is going to have to be either the first or the second one, right? Think about it. You can't have a 2 as the third one because what are the first two going to be, right? If it's increasing and they're all different, no way to put a 2 here. But anyway, let's just say that, you know, a 2 is one of these first two elements. Okay, I've got a square root of 2 in there. The problem is I got to turn this whole thing rational. How am I going to add something onto the square root of 2 in order to make it rational, right? I can't add enough square roots of 2 on to each other to make them overall rational. There's not any other square root that I can add to the square root of 2, or any combination of square roots that I can add to the square root of 2 to make it rational. Now, proving that is beyond the scope of this video or even the contest, but it's one of those things that you're expected to kind of realize, hey, wait a minute, there's no way I can add something onto the square root of 2 in order to make the whole thing rational. What does that mean? It means that there aren't any 2's in here. You know what else that means? There aren't any 3's, there aren't any 5's, 6's, 7's, 8's. The only things that there can be are values of p that make the square roots rational already. Okay, so what does that mean? That means that our p-values are the square numbers. So 1, 4, 9, 16, all the way up to 100. Okay, so if our possible values are the square numbers, that means well, I'm not going to have 100 terms in my sequence, that's for sure, because there's only 10 things I can choose from, and they all have to be different, right? So, so actually, the longest that this sequence can be is 10. Now, if I put in anything that's not a square, then when I take the square root, it's going to be irrational, and there's no way to make it rational by adding something else. So all I can put in here are square numbers, and I can put any of them, right? It doesn't matter. Any combination of these square numbers is going to get me where I need to go. So we're almost done, basically, right? We take a look at this and we're like, well, I can either have the 1 or I cannot have the 1. That's 2 choices. I can either have the 4 or I cannot have the 4. That's 2 choices. The 9, it can either be here or not, right? So every one of these, I have 2 choices. There are 10 square numbers that I'm listed, so I've got 2 to the power of 10, 1,024 choices. Now, don't pick C already. Hold on. Let's double check this for a second, because 1,024 represents all the possibilities of what am I going to take, what am I going to exclude. There was one thing that we have to pay attention to, though. These are non-empty sequences, right? So of these 1,024, I want you to think through all the possibilities, right? There's going to be one, and you can run through the combinations of 10 choose 0 up to 10 choose 10, right? There's going to be one possibility that has alternative. There's going to be 10 possibilities that have 9 of these numbers and exclude one of them. There's going to be 10 choose 2, which is 45 ways that we're going to have 8 of these numbers and exclude 2 of them. And we've got all of our combinations, right? But one of those combinations is where we have one possibility where we have none of these numbers. Now that is not allowed because it says that they have to be non-empty sequences. So what we're going to need to do is take that 1024 and realize that there's one of these that doesn't work because it's the choice where we've picked not to have any of these squares, and we subtract that and get 1023. And that's how it's done. Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.